earlier lectures, we have looked at functions and we will still be looking at functions. We have also looked at the library functions, and just to recapitulate that whenever we are using some library functions in our program, then we have to some mathematical library functions, then we have to hash include math.h, and while we link it, while we compile it, we will also have to link it with that maths library with the option -lm, as you have seen. Now, today, since now we have got an idea of what functions are, let us have a relook at our old friends Scanf and Printf, which we were using a number of times. Now, Scanf and Printf are nothing but functions. These are also some library functions, and those are included whenever we include stdio.h. Now, you see Scanf and Printf being functions, when we enter data, let us look at this structure. We write Scanf followed by some parameters. We have also seen that a function is nothing but something like f, say function name followed by some parameters. Here this Scanf is that function name, and the parameters are the control string. That means, say for Scanf you have got something like %d and then x, all right. So, this is the control string and these are the arguments, all right. So, both of these are arguments to the function Scanf. So, Scanf is nothing but a function. So, whenever in my program, suppose I am writing a program and here I use Scanf with some parameters like this, then it is nothing but a call to a system function which actually does the task of reading the data from the input device. Okay. So, a control string refers to typically the data types of the arguments. We have seen %d, %f, etc., and the arguments are pointers to data items in memory. These arguments in Scanf are, what are the typical arguments in Scanf? They are, say whenever I use Scanf, say %d, then and a or something like that, right. Now, this and is nothing but an address of the variable a. So, in my memory, wherever the variable a is, the compiler has allocated this memory location for the variable a, and I am passing the address of that. So, that means it is a pointer pointing to some address or a pointer that is pointing to this particular location in the case of Scanf. Okay. So, that is why it said that the arguments, these arguments arg1, arg2, argn are representing nothing but pointers to data items in the memory. So, the example, a typical example is say %d, %f, %c, which is nothing but the control string. It is designating that and a is an integer and a is a pointer to a, and average is a floating point number and average is a pointer to average, and type is a character type variable and type is, why is type a character type variable? Because I have put in here and c. Since I have put in here and c, that tells me that this type is a character type variable and type is a pointer to the variable type. The control string consists of individual groups of characters with one character group for each input data item. So, this is one character group for this data item. Okay. So, percentage, we have seen that percentage sign means it is a conversion character. The commonly used conversion characters, we have already seen some of them. These are known to us. Percentage D is for decimal or integers, percentage F for floating point numbers, percentage C for single character, percentage S is a string. Whenever I am reading something variable as a string, we have discussed that. In that case, we are reading that string using percentage S, and that is a string is always terminated by null character. Similarly, percentage X denotes that the number that I am reading is a hexadecimal character. Hexadecimal means decimal is with a base 10, that means 0 to 9 are my elements. So, all the numbers I am describing using 0 to 9, that is my alphabet set, whereas in the case of hexadecimal the base is 16, and so a base being 16 I have got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, these 10 numbers, followed by A for 10, B for 11, C 12, D 13, E 14 and F 15. So, up to that 0 to 15 I can have, so in a 16 when I work with a base 16, and that is known as hexadecimal. Now, so you can just establishing a similarity analogy with our binary number system that we have seen. We can have say a number A B. Now, A B is a string. So, the position position weights are, first position is 16 to the power 0, second position is 16 to the power 1, third position is 16 to the power 2, like that. In the case of binary, we had the first position weight was 2 to the power 0, 2 to the power 1, 2 to the power 2, like that, right. Now, and each of these positions can be filled up in the case of binary by 0 and 1, but here in the case of hexadecimal it can be filled up with any of these 0 to A, 0 to F. So, A B, when I say, that means B is what in decimal? B is 11, 12. So, 12 times, what is the weight of this position? 16 to the power 0 plus A is 11. Sorry, I'm sorry. This is 10, 10 to, sorry, let me correct that. A is 10 and B is 11. So, it is 11 into 16 to the power 0 and 10 times 16 to the power 1. So, how much is that coming to? 160 plus 11. So, that is the number 171. Now, if I had to represent 171 in binary, I would have required much more number of bits, right. And since it is hexadecimal, another so here we using hexadecimal, I am being able to do that using 2 hexadecimal bits, which we can call hexets. But let us see, A being 10 and B being 11, in binary what would that be? B is 11, that means 8, 2, 1, this is 11, and 10 is 8, 2, that is all. So, I would have required 4 bits for representing 171, which I am representing using 2 hex sets, all right. So, that is a hexadecimal integer. So, if I print something in hex in this format, then it will be printed like 171 will be printed as AB. Otherwise, it will be printed as in the binary number or in the decimal number. If I do it with percentage %d, it will be printed like this. So, it was a brief introduction to hexadecimal numbers, but that you can read up yourself. So, let us proceed. We can also specify the maximum field width of a data item. Now, this is something I had purposefully evaded till now, just to not to make the things complicated. I want that you first get accustomed to the normal features of C. Now, but now we are in a, now I think you are in a position where you can write programs. Here I am introducing the notion of field width. A data will be printed within a width, right. So many positions will be given to that data item. The number indicating the field width before the conversion character. For example, let us make it clear. For example, percentage 3D, percentage 5D for A and B. That means, A will be expected to be of, A will be expected to be of 3 positions, say it is 3D decimal 171, whereas B will be 5D. So, there will be 5 positions for this. 1, 2, 3, 4, 5. So, maybe 527, 3, 2. Now, if I want to print 171 or read 171 using the format 5D, then what should I print? I should print I should provide the data for the 5 fields. I should put it blank blank or 0 0, then 171, assuming it is right justified, all right. So, this is the width, that we are talking about. We can specify how many, what is the, when I am reading, what is the format of the data, how many widths, how many positions it is taking for as the data, right. So, say for example, if I have 171,532, then 7, then if I read it, the first data I feed is this, I type through the keyboard, and if it is in percentage 3D, it will be fine. Okay. So, I will read that. Again, now coming to writing. Now, this printf is also a system function. Just like scanf, printf is also a system function, and here also, since you know already how do you write printf, I write printf using a control string within the double quote and then followed by this number of arguments. So, the same thing will hold here. Control string refers to the string containing formatting information and data types of the arguments to be output. So, now here while printing the arg1, arg2, these are the representing the individual data items. In the case of scanf, they were pointers to the data items. Here they are individual data items that I have told you earlier. That is why we use ampersand A, ampersand B in the case of scanf, but in the case of printf we just write A B, okay, because this A B are directly referring to the variables, the data items. The conversion characters are the same as scanf. So, let us look at some examples. Printf, the average of A and B is AVG, and that AVG is percentage %F. You can see that, right. So, AVG is a float. Now, I could have also done this, that so this is nothing but just the control string. Here you see I have said that 3D, 3D, 5D. So, A will be printed. So, when it will be printed, A will be printed, there is no new line here, you can see. So, A, B and A times B plus 2 will be printed side by side. So, A will be printed on 3 fields like say 171, B will be printed on 3, next 3, there is no space given. So, this will be B 6, 3, 2, and the expression here A times B plus 2 will have 5 spaces, 5 positions given. Now, obviously, if my data for result for A was 1712, then only this much will be printed and the rest will be left out. Okay. So, here you see for the percentage F. Now, for this I think it is not very difficult to understand. You can read them in the any textbook, it is clearly discussed in most of the textbooks. So, I recommend you to go through these formats, and as you practice you will keep that in mind. But just to tell you this, so floating point number will have two parts, right. One is the integer part and the other is the decimal part. So, suppose here when I say 7.2 f, x is a floating point number which is being printed in the format 7.2 f. So, this entire width is 7 positions and the 2 positions here are kept for the decimal. So, these 2 are kept for the decimal, and we imagine we will have a decimal point here and the rest 5 will be for the integer part. For y, what will happen? For y, the total field is 5, out of which, so total field is 5, out of which only one position is kept after the fraction. So, here I assume this point, and so there are 4 positions to represent an integer and 1 position to represent a fraction. So, if my result was 101.52, in this format if I print that, then I will get 0, 1, 0, 1, or this 0 can be may not be printed. So, 101.5 because I did not have the space for this. Okay. Many more options are available, you can read from the book and we will do this later. Now, coming to a very important concept that is function prototypes. This is possibly a new name that you are getting. What are these prototypes? Now, we are going to write functions, and those functions, one of the functions which must be there is the main function, right. Typically, people write first the main function and then the first the functions and then the main function, but you are free not to do that also. So, usually a function is defined before it is called. So, typically what we do is when our program starts, so we start the program starts from here, we define we write a function with some parameters here, and the body of the function is here, and then we write say main, and inside main I call f1 this assigned to some variable x, like that. So, this is the typically some what we do, all right, after I did this include stdio.h. I started with the function first. That is one option. Okay. Now, but always that is not done. So, main in that case, if I define the functions first, the functions that I am going to use, I have thought about that, I have designed them. So, first I write those functions, and after that I write the main function. In that case, the main is the last function in the program. So, in that case, the compiler, so I have got my program here, entire program here, and I have defined the function f1 here, I have defined function f2 here, and when I write main here, and in main I refer to f1, f2, whichever whenever it is required. Now, let us look at the compiler. Think of yourself to be the compiler. Now, if you had started compiling the main first and you would have come to f1 and f2, then you would wonder what is that f1 and f2. No variables are defined, right. You would have taken just like if you had written x in the main, some function f1 some function like f1 a b, right. Then this f1 is not recognized, I mean you do not know about that here. But if you write it before, the compiler will actually start looking from the beginning of the page or beginning of the program. It will understand, okay, a function has been defined here, I understand that function. So, I know that, and I know what this function does, it compiles that, and f2 also. So, when it comes to in this direction, when it comes to the main and finds f1 and f2, it already knows that. So, there is no problem. So, easy for the compiler to identify the functions when it scans through the file. This is the file, right, the whole thing is the file. However, always that is not done. Many programmers prefer a top down approach, that I will first define main and then I will put the functions. But then what will happen to the compiler? The compiler, if it starts with main, it is starting from the beginning, and if it encounters f1 or f2 in the body of the main function, then it will get confused. What is it? Just like if I had got a variable x being used and it is not defined, there would be an error because I do not know what this x is, what type it is, right. So, I have to declare that beforehand. Similarly, for functions, there must be some way to tell the compiler that is the function, and for that function prototypes are used. Function prototypes are used. Okay. Let us look at this is needed if the function comes later. So, function prototypes let us look at are usually written at the beginning of the program ahead of any other functions including main. Say for example, this is a prototype. This is a prototype, int GCD, int A, int B. Okay. So, A and B are the parameters and GCD is a function of return type int. So, I know just by this prototype, by this I know the basic whatever is the body of GCD, I know its interface, I know its input output. What is its input output? There will be some A coming, some parameter, there are two parameters, internally they are named as A and B. I also know that this is an integer and this is also an integer, and I know that its name is GCD, and I also know that its output is an integer. Whatever is in between I am not bothered about right now, this much I know. So, I will expect whenever GCD will come, I will allocate 2 integer space for that and 1 return facility should be there. Similarly, let us look at the second one, div 7 int number. So, the prototype tells that it is a function, its name is div 7, you can guess div 7 means is testing the divisibility by 7, and there is one integer that is being fed and that integer's name is number, and void is a type, that means it is not returning anything. Maybe it is printing something from here, it just takes a number, it sees whether it is divisible by 7 and prints it here, divisible by 7, not divisible by 7, whatever. You know how to find divisibility by 7. So, you take the number and find the mod of that with 7, and if this is equal to 0, then divisible by 7, otherwise not. So, that is in the body of the function, and here we just do the printing. So, I am not returning anything to the calling function, that is why this is known as void. Void is a valid type. Okay. Note the semicolon. Now, here this is very important, whenever for hash include stdio.h I did not give a semicolon, but whenever I am declaring a function prototype, I have to give a semicolon, just as I had given a semicolon when I declared something like int x semicolon. Similarly, here this semicolon is very important, it is just like a declaration. So, the argument names can be different, but it is I mean it is a good practice to use the same names in the function. Now, so what is being said here is that although I am using here showing that A and B, but when I am actually writing the function later, say when I am writing the function later, when I write later on int GCD, I can make space, I can write int GCD int x comma int y, that is also possible, okay, because my prototype just said that 2 integer places. Now, actually I can change the name of the place, but that is not that important. I mean that is not, I mean usually it is better if we can keep both of them. Okay. So, here is a function prototype example. I will continue with this in the next lecture. I will discuss this and we will move to some other important feature of function like parameter passing in the next lecture onwards.